In 1987, a test accident at Zone Falcon in Nevada desert has been conducted. The spill of liquefied natural gas caused an intense evaporation and creation of huge amount of flammable vapor in atmosphere. The result is a horrific deflagrating burning cloud which ignites and destroys everything in near vicinity. In later decades, scientists and safety engineers from all over the world faced this threat and started a thorough analysis of the phenomena of accidental spills. After years of research, the conclusion has raised up that the key factor of quantitative consequences assessment during spill accidents is evaporating rate of liquid phase. So the models of evaporating liquid pools have been developed and the phenomenon of evaporation process has been studied well. Let's talk about the phenomenon of evaporation process itself. Consider a vessel with liquefied natural gas inside the walls. Next moment, a rupture accident occurs and natural gas spills on the surface. Now liquid phase contacts with ground, air, and sun. It is need to be mentioned that exists two possible ways of evaporation: boiling and evaporation under temperature lower than boiling point. When liquid in spill is boiling, then heat amount going inside liquid pool from ground, sun and air determines an evaporation rate in such a manner, where W air, W sun, W ground are heat fluxes from air, sun and ground respectively. H evap is evaporation heat. When liquid has a temperature lower than boiling point and evaporation without boiling exists, mass diffusivity starts to affect all the process of evaporation. You may remember that phase equilibrium can occur only if amount of outcoming molecules per second equals to amount of incoming molecules per unit time. So, equilibrium state can be characterized by certain amount of molecules in a unit volume, or concentration. The greater concentration of substance in vapor phase comparing to equilibrium concentration, the greater amount of molecules in comes to liquid phase and vice versa. So this is the moment when diffusion starts to work. Let's build a graph of dependence of the concentration of evaporating substance in air versus height. According to Fick's law, the greater a gradient of concentration, the greater intensity of mass flow in the direction of lower concentration. A bunch of environmental parameters, such as temperatures of air and liquid, specific diffusivity of substance in air, and wind speed affect diffusion process. The greater the wind speed, the greater a gradient of concentrations near boundary layer, which is obviously a surface of contact of liquid pool and atmosphere. It happens because wind all time pushes air in evaporation area, decreasing concentration of evaporating substance in a vicinity of boundary layer. At the end, we are going to talk about temperature of liquid phase. As it was mentioned before, a heat exchange between liquid pool and ground, air or sun, as well as heat loss to evaporate liquid define all the process of evaporation. The greater heat flow from the environment inside the pool, the greater a temperature of pool, the greater the evaporation rate due to greater partial pressure of vapor. At this moment, there are a lot of models that describe the phenomena of evaporation in similar way, and the science of risk assessment continues to apply state-in-the-art decisions of physical effects modeling techniques to be able to analyze the actual risk on new competitive level. And evaporation model still stay the key to estimate the amount of hazardous substance in the environment and possible consequences of realization of such impact factors as explosive wave, fireballs heat, and toxic load. That's all. Thanks for watching. Until next time.